بسم الله الرحمن الرحيم. Yeah, I will start now. We'll finish the squeeze theorems. Now we'll go to the special limits. Special limits. Actually, we have three special limits. This one, limit sine x over x as x goes to 0 is equal to 1. Limit 1 minus cosine x over x as it goes to 0 is equal to 0. And we have this about the e. 1 plus x to the power 1 over x as it goes to 0. This is e. So let me concentrate with the first two. I will do some problems with the first two, then I will go to the third one. Yeah, before I continue, I need to be sure that we have these conditions or these cases. Okay, if I have sine theta over theta equal 1, this is the same one. Huh? Theta over x is the same. If I have theta over sine theta, if I just reciprocal of this, it's the same. Reciprocal of 1 is 1. So there is nothing to worry about. Now, if I have limit theta goes to 0 of sine a theta over theta. Okay. So what shall I do? Just to get this formula, if I put a here, yeah, I'm trying to use a different color, but did not click. Okay, I have a here and a there. Okay, now we did nothing. I did nothing. I multiply by 1. Huh? So that will not change the formula. Okay, but now what will happen? This one, if I take it aside, huh? So look, limit theta goes to 0 of sine a theta over a theta. If I let t equal a theta, I'm getting what? Limit sine t over t. Now, if theta goes to 0, then t goes to 0, and that is 1. So this goes to 1. 1 times a, I'm getting a. So I have this formula. If I have sine theta over b theta, the same idea. Huh? This b, take it away and put a here and a there. So this limit will goes to 1, so I have a over b. By the way, if I have tan theta over theta, it's the same idea. Why? Because if you look at it, the same answer, I mean 1. This will be limit theta goes to 0, sine theta over cosine theta times theta. This limit is 1, and cosine 0 is 1, so the answer is 1. And you can do the same trick with tan a theta over b theta, so you can deal with this a. Not only that, if I have sine ax over sine bx, I can do this trick. Limit x goes to 0. I divide by x in the numerator and denominator. So I have sine ax over x over sine bx over x. This goes to what? I know it. This goes to a. So this is equal a and the one b. So I have this formula too. Okay. Now let us do these problems one by one. This is very clear. I put 4, and my answer is 4 times 1. So in this limit, by letting t equal 4x, you get 4 times 1, and that is 4. What will happen here? Multiply by 7. Let me do it times 7 or 7, yeah, times 7. And I need to multiply by 7 here. This, by letting t equal 7x, I'm getting 1, so that will be 7 over 4 times 1, which is 7 over 4. X cotan, I can make this x over tan x. And I know that tan x over x as this goes to 0 is equal to 1. The reciprocal of 1 is 1, huh? So that will not make a difference. So that will be 1. Okay, let us do these problems quickly. Sine 4x over x, that will be what? 4. 4, done. This one, I divide by x, numerator and denominator. And that give me what? 5 over 6. This is 2. 3. We did this, huh? 4. Limit, this one we did it, huh? And this one, huh? It's the same, huh? X goes to 0. What I will do, I divide by x, numerator and denominator. Cosine x minus 1 over x. And this is sine x over x. I'm doing what? I'm just multiplying by 1, which will not make a difference. But be careful in that. 1 minus cosine x over x, as it goes to 0, that gives me 0. And the same thing, if it is cosine x minus 1 over x, it will be minus 0, which is 0. So there is nothing to worry about. So that gives me what? 0 over 1, which is 0. 5. Be careful, 5. 5, the limit goes to what? To pi, not to 0. So I cannot apply all of these formulas just if x goes to 0. Okay. So now we'll do this. Limit x goes to pi of sine 2x over sine x. If I substitute, by the way, if I substitute in all of these problems, you are getting 0 over 0, huh? So you cannot continue. Okay. Now what will happen here? If I substitute, I'm getting 0 over 0. Okay, but I know sine 2x. I know that sine 2x is what? 2 sine cosine over sine. Then I can cancel sine with sine, like what we did. Now substitute 2 cosine by. Cosine by is minus 1, so that is minus 2. Okay, last one. Limit x goes to 0 to x minus sine x over x. What is my first step? Divide by x. Now we divide this. I have 2x over x. Let me do it in steps. Minus sine x over x over x over x. Now this is 2. So I have 2. This one goes to where? Goes to 1. So I have 2 minus 1 over 1. The answer is 1. Okay. Now let us do all the exams problems. Let us do all the exams. Okay. Sine 60 over 2t. Yeah. Yeah, very clear. This is, I can do it. Sine 60. I have here 2 times 60. And I put 6 here. So 6 with 6, this is cancelled. So this limit will be 1. So I have 6 over 2 times 1, which is 3. So this is my answer. This one. Notice first, by the way, this is not a special limit, but since I notice first, it's x goes to pi over 4, huh? And the argument is x. Okay. But if I substitute, I'm getting 0 over 0. So it means I need to do something. That's not special limit, but you can think of it this way. Just define tan x as sine x over cosine x. And just do the calculation. Then something will be cancelled. If you do this, you're getting what? Cosine x minus sine x over cosine x, sine x minus cosine x. Now this with this cancelled. I'm getting what? Minus 1. So that will be limit x goes to pi over 4 of minus 1 over cosine x. And that's cosine pi over 4 is not 0. So I can't do the calculation. That will be cosine pi over 4. And cosine pi over 4 is what? 1 over square root of 2. So that will be minus the square root of 2. And that will be my answer. This one. Yeah, since cosine is, actually we took in 2.4, since cosine is a continuous function, I can take the limit inside. So that will be cosine limit theta goes to 0 by theta over sine theta. This is what? This is 1. So I have cosine by times 1, which is cosine by, and the answer is minus 1. That is minus 1. Sine x 1 minus cosine x over x squared. Yeah, if you think about it, it's an easy one. Just this is x squared. I make it x times x. And I distribute it sine x over x. 1 minus cosine x over x. This is 1 and this is 0. So the answer is 0. Easy one. Yeah, this one. Yeah. By the way, in each of these problems, if we substitute, we are getting 0 over 0. Huh? Yeah. Also, this one, we're getting 0 over 0. It will be cosine 0, which is 1 minus 1. This is 0. This is 0. This is 0. So I have 0 over 0. So I need to do something. So just distribute the limit. Be careful. When we have the formulas, I have cosine x with 1. With a 1 minus cosine x or cosine x minus 1 is the same idea. But sine is alone. Okay. So I will do this. I will make cosine x minus 1 minus 4 sine 3x over 2x. Now I distribute it as cosine x minus 1 over 2x minus 4 sine 3x over 2x. This goes to what? This goes to 0. So I have 0 over 2, which is 0, minus. This one goes to 3. So I have minus 4 times 3 over 2. That will be minus 6, which is this. Same idea, but now with tan. But I have 2 minus 2 cosine x. Who cares? I can take 2 minus 2 cosine x. I do the same trick. Tan 3x over 2x. That gives me limit. X goes to 0. Can take 2 common factor to see it. This is over 2x. It will not make a difference because that will go to 0 over 2x. So this is 2 cancel. And this limit goes to 0. And I have this goes to 3. So I have minus 3 over 2 times 3, which is minus 9 over 2. And that would be my answer. Okay. The same idea exactly. What will happen? This sine pi over 3 is square root 3 over 2. Just a number. But you make it sine pi over 3. It's only a number. Huh? So I have limit. X goes to 0. Square root 3 over 2 sine 2x. This is half cosine x minus 1 over x. Now distribute it. It will be square root 3 over 2 sine 2x over x plus half cosine x minus 1 over x. This is 0. This is 0. This is 0. This one goes to where? To 2. So I have square root 3. Square root 3 over 2 times 2 plus 0. So the answer is square root of 3, which is this. The same thing. I divide by, so this, I need to divide by theta in the numerator and the denominator over, here I have theta over theta. I'm doing it in details. So you're getting what? 2 over 1 plus 1, and the answer is 1. 2 over 2, which is 1. Same idea. You divide by, I'm combining the questions which is with similar ideas in after each other. 3x over x. Yeah. So that will be what? This is goes to 3. This is goes to 5. And this is 2. So you have 2 plus 3 over 5. And the answer is 1. Same idea, but now I have cosine. So I need to be careful. I need the cosine with the minus 1. So it will be x. Yeah, let me do it in details, in steps. X minus cosine x minus 1 over 2x plus sine x. Now I divide by x in numerator and denominator. I have x over x cosine x minus 1 over x. I have 2x over x plus sine x over x. This is 0. This is 1. This is 1 minus 0 over 2 plus 1. That will be 1 over 3. That will be my answer. So I need the same idea. Let me do it quickly. Sine x over x, x over x. That will be 1 over 1 plus 1, which is half. That will be answer. Okay, the piecewise function. So it means I need to check the limit from left and right to be sure the limit exists or not. So I will do limit is goes to 0 from left. From left, so I need this function where I need the special limits. 1 minus cosine x over sine x. So I divide by x, numerator, denominator. That give me what? 0 over 1, where the answer is 0. This is the limit from the left. Limit from the right. I need this function where I need to do calculations, factoring or something like this, or open the square. Yeah, you can open the square. I think it will be easy. That will be 1 plus 2x plus x squared minus 1 over x. This is cancelled. Now I can take x common factor. So I have 2 plus x with x over x. This is cancelled. So I'm getting 2. So this is not similar to this one. So that means the limit does not exist. Limit from right, not equal limit from left. But the thing is, the new thing, no, I'm applying to find the limit from left, I need the special limits. You cannot do it unless you have the special limits. Okay. This one, when I need to do some calculation. Yeah. That will be what? If I substitute, I have 0. This is 0, 0 over 0. All of these problems, you have 0 over 0. So you cannot, it means you need to rewrite the function a different way. Let me take tan common factor over x cubed. Okay. So I have limit, x goes to 0, tan x over x. Oh, before that, what is 1 minus cosine square? 1 minus cosine square, this is what? This is sine square of 2x over x cubed. So that will be limit, x goes to 0. This x cubed, I distribute into x times x times x times sine 2x over x times sine 2x over x. So that will be 1, 2, 2. That will be 4. That will be my answer. This one, same idea. I took common factor here. So I have sine 3x tan 5x. I have x squared from here. I have 3 minus 5x squared. So this limit, now x squared I can distribute it as x times x. And the remaining is 1 over 3 minus 5x squared. Now I can distribute the limit easily. So that will be 3. That will be 5. That will be, substitute the 0, 1 over 3. So the answer is 5. Yeah, this one, it seems to be a lengthy one. No, just so I divide by theta. Numerator and denominator. Be careful. I have this with this and this with this. So I have limit. Theta goes to 0. I have sine 2 theta over theta plus tan 3 theta over theta plus 1 minus cosine 5 theta over theta. All of this over sine 3 theta over theta minus tan 2 theta over theta plus cosine 6 theta minus 1 over theta. This difference. What will happen to it? It will go to 0. And this is goes to 3. This is goes to 2. This one goes to 3. This one goes to 2. And this one goes to 0. Also, this is, you can see it better if you let t equal 5 theta. You can see it. Huh? So, I mean, I'm talking about this one. So they have 2 plus 3 plus 0 over 3 minus 2 plus 0 plus 0 minus 0 will not make a difference. That will be 5. Okay. Yeah. Sometimes this dividing by x will not help. Secant x minus 1 over x squared. That's still 0 over 0. Okay. What shall I do? Sometimes you need to multiply by the conjugate. Or multiply, I mean, try to rewrite the function in a different way. So in this case, I multiply by secant x plus 1 over secant x plus 1. Why that will help? Since I have x squared there, that will help me in what? I have secant squared minus 1 over x squared for secant x plus 1. Yeah. What is secant square minus 1? This is tan square. So this will be limit. X goes to 0. X goes to 0. Tan square x. I can make it over x squared secant x plus 1. Okay. And I can rewrite this one as what? Tan x over x times tan x over x 1 over secant x plus 1. That will be 1. That will be 1. Now I can substitute. Secant 0 is 1. So it will be 1 over 1 plus 1. And the answer is half. That will be my answer. This is the same thing, but I multiply by 2. Multiply by 2. So it will be 1 over 4. Huh? I know this is half. So it will be 1 half times 1 half, which is 1 over 4. Huh? This is 1 over 6. Huh? No need to do it again. Yeah. Yeah. This one. Yeah. If we divide by theta, still you have the problem, huh? If we divide, now assume I did the same problem again. I did the same idea. I divide by theta. I have theta, tan theta. Okay. Over theta. This is 0. And I have still 0 here. So that will not help. I'm still having 0 over 0. So that will not do it. Because of that, I need to do what? I need to do the same trick I did before. Multiply by the 1 plus cosine theta in the numerator and the denominator. Let us see what will happen. That will be limit. Theta goes to 0. 1 minus cosine squared. Let me do it in steps. Be careful here. You have tan theta. 1 plus secant theta. 1 plus cosine theta. Okay. What is 1 minus cosine squared? It's sine squared. Over theta. Tan theta. 1 plus secant. 1 plus cosine. Okay. Now sine theta, I have one sine, I take it with theta, that will give me 1. And I need to check sine theta over tan theta. What is this? Sine theta over tan theta. That will be sine over sine over cosine. So sine with sine cancelled, I have cosine theta. Okay, so I split this into 2 parts. Sine theta over theta. Sine theta over tan theta. And I keep the rest, because the rest cannot be 0. Huh? This is 1 plus 1, 1 plus 1. As theta goes to 0. Okay. This is 1. There's sine theta over theta, there's cosine theta. Cosine 0 is 1. And I have this is 1, 1 plus 1, 2, 1 plus 1, 2. So the answer is 1 more. The idea is just we rationalize. Or I mean, we multiply by this one, not rationalize, multiply by 1 plus cosine theta, and that will fix the problem. Same thing here. If we do the calculation, don't forget this is x cubed. So it takes 2 sine x, sine 2x is 2 sine cosine over 3x cubed. That will be limit. I took 2 sine common factor. I have 1 minus cosine over 3x cubed. Okay. Now if I divide by x, assume I did this, which will not give me a result, but I will see it. 2 sine x. I have, assume I divide yeah, I divide, or let me split it. Not divide, split this. I say 2 over 3 sine x over x, 1 minus cosine x over x. I need 1x. This is give me 0, but now I have 0 over 0, and this is give me 1. So that idea will not help. I have 0 over 0. So that will not fix the problem. So what I will do, multiply by 1 plus cosine x over 1 plus cosine x. And see what will happen. That will give me what? 2 sine x. I have 1 minus cosine square, which is sine square, over 3x cubed. So I have sine cubed over x cubed, which will give me now the 1, huh? And don't forget 1 plus cosine x here, huh? This one. So I have limit, x goes to 0, 2 sine x, 2 over 3, sine x over x, sine x over x, sine x over x. Don't forget the last one, 1 plus cosine x. I'm doing it this way so you can see it easily. 2 over 3 times 1 times 1 times 1 times 1 over 2. The answer is 1 over 3. That will be my answer. Okay. Now we'll go to problems where the argument is not x, and the limit goes to minus 3. But if I substitute, it will be sine 0. Okay? Okay, so what shall I do? I know my problem is sine theta over theta. This is equal to 1 as theta goes to 0. So we'll do this trick. Now we'll let t. First, I need to simplify the numerator, the denominator. That will be x plus 3 times x plus 5. And I will split this into 2 parts. Sine x plus 3 over x plus 3, where I will show you this is 1 times limit 1 over x plus 5. This is clear. This is what? Substitute easily, you get 1 over 2. Okay. Now for this one, since this is the first one, I let t equal x plus 3. I want this argument to be t or theta. Let me call it theta. So we have the same like this one. So I have what? Limit sine theta over theta. And notice what? If x goes to minus 3, x goes to minus 3, minus 3 plus 3, so theta goes to 0, which is my formula, times half. Or times the limit, half, let me do that. X goes to minus 3, 1 over x plus 5. That give me 1 times half, that give me half. But this is just substitution. The same idea here in this question too. I will let, yeah, first I need to rewrite it. I need to simplify or factor the denominator. Now I can split it. Yeah. Now, in this case, I will let t equal, or let me split it into two limits. This is easy limit. This is, I need to let t equal x minus 1. So I have limit t goes to 0. Since if x goes to 1, this is goes to 0. Tan t over t. I know this is 1. And times the other limit. What you will get, this is 1. This is 1 over 3. So the answer is 1 over 3. Okay. Same idea. Limit x goes to 1. Sine, this is 2x minus 1 over x minus 1 times x plus 1. I need 2. So I put 2 and 2. So this things, as x goes to 1, like what we did before, it will go, as x goes to 1, yeah. So the argument of sine, it will be sine 0 over 0. These things will, by letting t, huh? Let me do let t. Let, or I can split it first. That will be limit x goes to 1. Sine 2x minus 1 over 2x minus 1 times the remaining limit x goes to 1, 2 over x plus 1. So this is, if I let t equal 2 times x minus 1, this will be limit t goes to 0, sine t over t. Now, why do I have music t or theta? Yeah, sometimes it's theta t, no problem. These are just dummy variables. Limit x goes to 1, 2 over x plus 1. This will be 1. This is 2 over 1 plus 1. So the answer is 1. 2 over 2, which is 1. Same idea. Limit x goes to 2. X minus 2 times x plus 2 over sine 2 minus x. Oh, this is x minus 2. I can make it 2 minus x by taking minus sign outside. So by letting t equal 2 minus x, this will be 1. And your result is minus 1 times 4, which is minus 4. You can do it by the let t. Huh? You can do let t and do the calculation, like what we did before. Okay. Now, when you look at it, you feel there is something, there is some problems here. No, there is nothing. What is this? Cosine theta minus sine theta all square. Here is the catch. Square, that will be cosine square minus 2 cosine sine plus sine square. Cosine plus sine, this is 1. Yeah, this is 1 minus 2. Yeah, it will be 1 minus 2 cosine theta sine theta. And what is this? This is sine 2 theta. Okay, so let me now rewrite this. Limit theta goes to pi over 4. C tan 2, 1 minus sine 2 theta over 1 minus sine 2 theta. Okay. To have the same argument, this is 1 minus sine 2 theta. I need the 2. So multiply by 2 and 2. Now, I let t equal 1 minus sine 2 theta. See what will happen. This limit will be limit 2c, all of this, times 2. Huh? Times 2. Let me make it times 2. 2, 1 minus sine 2 theta, which is the argument of tan. That will be tan theta, tan t, sorry, tan t over all of this is what? T. Now be careful. Now, as theta goes to pi over 4, I have sine pi over 2, sine 2 times pi over 4, which is sine pi over 2. That is 1. 1 minus 1, that will be 0 times 2, so it goes to 0. And what is the answer of this? 2c. So this is goes to 1, and this is 2, t goes to 0. So the answer is 2c. Yeah, which is this one. Yeah, by the way, this is just to make it more complicated. Looks more complicated, but it's nothing, huh? Look at this one. Let me simplify this. All square. This is 1 minus cosine x, 1 plus cosine x. This is this one, all square, square, square. So I have limit x goes to 0, sine 2, 1 minus cosine x, tan 1 minus cosine x over 1 minus cosine x. Let me write it this way, 1 minus cosine x. This, I don't need to do it. But what I will do, I'll take one with tan and one with sine. But there is a need of 2 here. So let me split it this way. Sine 2, 1 minus cosine x over 1 minus cosine x. But I need the 2, so I have 2 and 2. Okay. Times tan 1 minus cosine x over 1 minus cosine x times the rest, which is 1 plus cosine x all square. This will not make a problem because if I substitute the 0, it will be 1 plus 1 square. We'll have no problems. Okay, now in this one, if I let t to 1 minus cosine x, then I have what? Sine t over t, and as x goes to 0, cosine 0 is 1, it will be t goes to 0. In this one, I let t equal 1 minus cosine x. The same thing. I have t equal 0. So that, yeah, if I split the limit, it will be limit t goes to 0, sine t over t, this one, and this one tan t over t, and this is just, let me do it in steps. This is line times limit t goes to 0. I need to split these 3 problems, huh? Each one I solve it in a different way. So I have tan t over t, and the last one, limit x goes to 0, because I don't need for any changes here, huh? But here I have t 1 minus cosine x, the argument of tan. Here the argument is 2 minus cosine x, but I'm getting the same answer. That will be 1 over, don't forget the 2. There is a 2 here, huh? I have 2 here. So this is 2. This is 1 plus 1, 1 over 4. So the answer is half. That will be the answer. Yeah. Okay. Now we need to talk about this special limit. We don't have that much problems in that one. For this one, let me do the special limit. Huh? Let me talk about it a little bit. The third special limit, huh? Which is limit x goes to 0, 1 plus x to the power 1 over x. That should equal to e. Yeah. Let me just change it a little bit. Assume I have this problem. Limit x goes to 0, 1 plus ax to the power 1 over x. Or to the power b over x. Who cares? Or b over x. What will be that? Use this trick. Let t equal ax. Since I want to go to the same format. That will be limit x goes to 0, t goes to 0. That will not make a difference. This is going to be 1 plus t. Be careful here. You know what? Let me do it here in details. I think better. Limit. Because you have a formula we can use later. b over x. That will be limit. I let t equal ax. Limit t goes to 0. 1 plus t to the power. Oh, this I don't need it. Since I did it again. Now what will be the power? Now, if t equal ax, let me write this here. T equal ax, that means what? I need, yeah, this one will be b. What is x? That means x is t over a. This is over t over a. Yeah, that's the power, huh? So I have b over t over a. So that will be limit t goes to 0, a will go up. This is 1 plus t to the power ab over t. ab over t. Be careful now. Now, I have this, I can rewrite it. Limit t goes to 0, 1 plus t to the power 1 over t, all to the power ab. Okay. Now will give me this. I can distribute the limit. I take the limit inside, so that will be limit. Since the exponent is continuous function, it's domain, okay, over AB. And this is my E. So that will be EAB. So this expression is the same as e to the power A times B. So now let me simplify this one. This one, if you can think of it, this will be limit as it goes to 0. You can distribute this, that will be 1 plus 2x to the power 3x. So if you look at this is the same thing where a, this is a, this is a, and this is b. So it will be my answer, e to the power 2 times 3, which is e to the power 6. Let me do this problem. If r and q, what will be this limit? Now, my concern is with m. So my variable is m. Huh? So I have limit m goes to 0, 1 plus 1 over r times m to the power, this is what? R times 1 over pq. So this is 1 over, no, I need m, huh? I'm talking about m. My variable is m, huh? So this is what? R over q, yeah, this is, let me, R over mq, huh? So I have what? 1 over m times r over q. 1 over m times r over q. Or I can rewrite it. Yeah. So if you look at the formula, don't forget the formula, limit. The formula which I make, 1 plus ax to the power b over x. That will be what? E to the power ab. Okay. So this is my a, since I'm working with m. So my x is m, huh? And this is my b. Look at the formula. Yeah. So I have what? E to the power a 1 over r times b, which is r over q. So that is your answer, e to the power 1 over q. And that will be my answer. Okay. This is the last one in this video. Yeah, we have two problems here. This one, just factoring, huh? So let me do it here. If this goes to 0, x goes to ln 2, not 0. E to the power 3x minus 8 over e to the power 2x minus 2. You always need to check it 0 over 0. Huh? Okay. Now, this one, it will be limit. This goes to ln 2. Let me do it in steps. Ax cubed minus 2 cubed over ax squared minus 2 is minus 4. Okay, minus 4. So this is minus 2 squares. So you have difference of 2 cubes over difference of 2 squares. Okay. Now be careful in the calculation. X goes to ln 2. That will be ax minus 2, a2x, a2x plus 2x plus 4 over. This is just difference of 2 squares. So cancel this. Now I can substitute. Since I have nothing to worry about it. I killed the one which is making 0 over 0. So substitute, I have e to the power 2 ln 2 plus 2 e ln 2 plus 4 over e ln 2 plus 2. So I have this 2, take it as a power. I have 4 plus 2 times 2 plus 4 over 2 plus 2. I'm getting what? 12 over 4, that is 3. That's only this. This is 3. Okay, now we need to do this. Limit is goes to 1, then x over x minus 1. Okay. What I have the formula, don't forget the formulas you have in my mind. Limit x goes to 0, x goes to 0. 1 plus x to the power 1 over x. I don't need the a in this case. That will be e. So what I have here, limit x goes to 1, and it's something to the power. So I have 1 over x minus 1 times ln x. So I can take this as a power. I can take this as a power. So that will be limit x goes to 1 ln x. Yeah, ln x to the power 1 over x minus 1. Okay. Now I let t, since my formula I need x goes to 0. So I let t equal x minus 1. So this limit will be limit ln if t equal x minus 1. So it means x equal t plus 1. So I have ln t plus 1 to the power 1 over t. And look, if x goes to 1, t goes to where? To 0 from this. If x goes to 1, I have 1 minus 1, so t goes to 0. Oh, so I have now almost my formula, this one, but with the ln. So I take the limit inside, since the ln is continuous in its domain. I have 1 plus t to the power 1 over t. Okay, what is this limit? This limit is e. So I have ln e, and the answer is 1. So this is goes to 1. So this limit will be 1 plus 3, which is 4. So this will be my answer. Yeah, we have more questions. I call them miscellaneous questions. They are different ideas. I will do them in the next video. I don't like to have long videos, so let me stop this video, stop the recording. Thank you.